Okay, welcome. Let's get into the second document I prepared for preparing for Precalculus, and that is solving quadratic equations. So I broke this down into a couple of different ways we can solve quadratics. We could solve using the zero product property, solving by factoring, which is very important, and then as well as solving via the quadratic formula. So we're going to cover all three of these topics in that video, and just kind of break them down, how we use each one of these properties. So the first one is the zero product property. And, the zero product property is something that, we cover again in Algebra 2. And, it's really, again, just the remembering that when you have a product of two terms, two factors, two expressions that are equal to 0, then one of those numbers has to equal 0. So it's either A or it's B, or it could be both, right? So the zero product property tells us that when we have a product equal to 0, that we want that one of those values is going to have to be 0. So in this case, you can see for number 1, we have a product. Now, again, we don't have numbers here, but these are, these quantities, x minus 1 times x plus 2 is equal to 0. So by applying the zero product property, simply what we're going to do is set each factor, x minus 1 equal to 0, or we could say x plus 2 is equal to 0. Now, to go ahead and find what we call the zeros or the solutions or anything else, we're going to solve for the values of x that make either one of these quantities equal to 0. And we'll be able to confirm these results later in the course, and we'll see, why they're zeros and, what they look like. But for right now, we're just going to practice applying this property. So again, when you have the product equal to 0, it has to equal to 0. Then we just set each quantity equal to 0 and then solve. So in this case, I'll add a 1 on both sides. And therefore, I get x equals 1 is 1, 0, or solution in this case. And then in this one, I will subtract a 2 on both sides, and I get x equals negative 2 is my other solution. And again, we could also write this as a solution set. So I could say like negative, why did I do that as a negative 1? We could write that as a solution set of 1, comma, negative 2. And the pen's being a little weird. Sorry about that. All right, so let's go and work on to the next one. Now this one is, again, we still have the product. Now we don't have two binomials anymore like the last example, but we have a negative 4x times 2x minus 3 is equal to 0. So again, by applying the zero product property, we're going to set both of our factors, negative 4x equal to 0. I'm going to zoom in one more time and just kind of help me with my pen. And then the next one is going to be 2x minus 3 is equal to 0. Now in this case, to isolate the x, I'm going to have to divide by negative 4. And 0 divided by negative 4 is just going to be 0. So you can see that x is equal to 0. And further on, when we start doing this a little bit quicker, you can, really just relate that as long as I'm not adding or subtracting here, I can see that, my x is going to be 0 as one of my solutions. Over here, we have a two-step equation. So just remember to add the 3 first before dividing out the 2. Therefore, we have 2x equals 3, and then we divide by 2. And therefore, we have x equals 3/2. And again, going back to the understanding of the zero product property, both of these terms are solutions because when you plug them in for x, they make the quantity on the left-hand side equal to 0. You plug 0 in for x, you get a 0. 0 times anything is 0. You plug in 3/2 over here. 3/2 times 2 is 3. 3 minus 3 is 0. 0 times negative 4. 4 times 3/2, again, is still going to be 0. So both of these are solutions. And that's the same thing over here. If you plug in 1 into this expression, you're going to get 0. If you plug in negative 2, you're going to end up getting 0. Okay, over here, it looks like we have some like crazy radicals and whatever else. You can notice that I also flipped the 0 to the equation to the other side. But again, it doesn't matter, guys. We have two quantities multiplying that are equal to 0. So we set both of them equal to 0. And there, in this case, we have x plus 2 square root of 3 equal to 0. Now, again, this is a irrational number, and that's perfectly fine. We're just going to add this quantity. This is a whole quantity together. These are multiplied, but we're just going to add them over to the other side. So we'll add 2 square root of 3 onto both sides. And therefore, you get x equals 2 square root of 3. And then here, if you subtract, you're going to get x equals negative 2 square root of 3. And then sometimes, we'll write this as plus or minus 2 square root of 3 to represent the positive as well as the negative solution. All right, now let's get on to some factoring. Lovely, lovely factoring. So if you remember in the last, first video that I did, we just practiced factoring, just rewriting an expression as a product. And now you can see why that is so important, because if we can rewrite an expression as a product, we can now apply the zero product property to identify our solutions. And again, I'm not going to get very detailed into the factoring work. I do have other videos and other work that I give my students to improve upon their factoring skills. So I'm simply going to tell you how I do this mentally. I'll show my work, obviously, but tell you how to do this mentally so you can quickly be able to factor, because, I think factoring is one of those skills in Precalculus that students that really struggle with factoring, they start to struggle in Precalculus in general. And it's not because they can't understand the curriculum in Precalculus, but they're lacking some of those necessary skills. So that's why I wanted to kind of cover this. And again, it's not so much people are like, oh, I know how to factor, but a lot of these problems, what I did is I tweaked it, and that confuses a lot of students. So that's why I wanted to cover multiple examples here. So in the first one, I have solve by factoring. All right, so first thing we want to do is factor. We want to rewrite this as a product, because then we'll have a product equal to 0, and we can apply by the zero product property. So the first thing I want to do is, what two numbers multiply to give me -4, but then add to give me -3? And I think of all the numbers that multiply to give me -4, I'm thinking 4 and 1, 2 and 2. Well, the only ones that add to give me -3 is going to be a -4 and a 1. So I'll rewrite this as a binomial times a binomial. And therefore, it doesn't really matter the order in this case, because it's x times x. So because we have a coefficient of 1, which is nice. So I'm just going to write this as a +1 and a -4. And again, if you're confused, you can always check your work. I'm not going to go through it on this video because we covered it before, but you could always multiply them back to make sure they work. But 1 times -4 is -4, x times x is x squared, and then 1 times x is +3x, x times -4 is -4x, -4x plus positive x is -3x, so it works. So now I can just apply my zero product property, x plus 1 equals 0, and x minus 4 equals 0. So rather than showing my work here now, I can say x equals -1, subtracting a 1 on both sides, and then adding a 4 on both sides, x is equal to a +4. And there you go. All right, the next one. So now I just moved everything around, right? So again, we don't like factoring like in this form. You can, but I like to factor it when it looks something like this. So all I can need to do if I come across a problem like this is just rearrange the problem. So just make sure you keep the signs to where they're at. So that's a +x squared. So I'm going to write that as x squared. That's a +3x. So I'll write plus 3x. I don't need to write the plus x squared. You could, but it's non-needed, because we can, when it's positive, we know that is going to be a positive, so I don't need to write the plus. But this negative is very important to make sure you keep that, because you are subtracting a 4. So now you can see that this one's very similar to that problem. The only difference is there's a +3. So notice when I factored this over here, when I multiplied them, I had my middle term was negative. That's because the larger factor was negative. So if I want my middle term to be positive, why don't I just make the larger factor the one positive one? So you could rewrite this again over. You could keep the 0 there. It's not really going to mess up the problem. Or you could just rewrite it like this if you wanted to. It doesn't matter either way. But now what I'm going to do is I'm just going to switch the signs. X minus 1 times x plus 4. Why my 4s keep on doing that? Okay, so now again, what you can see here is, again, -1 times 4 still gives me -4, right? But now my middle terms add to a +3x. So therefore, so now my zeros are exactly the same, just the opposite sign. So I have x equals +1. I'm going to kind of speed through this, and x equals -4. Again, applying the zero product property and then solving for x, and that's how you get those two. Because my main focus here is hopefully that is understanding by now and you guys get this. All right, so here comes a very important one. Now we have an equation that is not equal to 0. So a lot of students get into this and they're like, should I square root both sides? Like, what do I do? And again, our idea of solving a quadratic by factoring is, or at least just solving any quadratic or even polynomial, if you want to find the values of x, set it equal to 0. We're looking for the values of x that make the equation equal to 0. That's something we'll get into later into the course, but for your intents purposes, when we're factoring and we're solving, we want to set it equal to 0. So I am going to add a 1 to the other side. Now I have 0 equals x squared minus 2x plus 1. Okay, so now it looks just like that problem. And now I can factor. What two numbers multiply to give me 1, add to give me negative 2? Well, 1 times 1 is 1, but 1 plus 1 is positive 2, so therefore I just need to make those negative. And this kind of comes into an interesting case as well. So I factor this into x minus 1 times x minus 1. And you notice this exact same solution here, right? It's going to be x minus 1 equals 0 and x minus 1 equals 0. So my only solution is 1. But that 1 happens twice, and we'll get into that. We call that multiplicity, if you covered that in Algebra 2. And that has some very interesting characteristics on the graph, which again we'll get into in the course. But just remember, if you're doing it twice, it's what we call a repeated 0. X equals 1 is a 0 repeatedly twice, which we call the multiplicity. Okay, so again, getting into this, do not take the square root of both sides. I see students do it all the time. They want to treat this like a linear equation. It's not a linear equation. You have an x squared on the left side and you have a 5x on the right side. So we don't want to apply our inverse operations when we have multiple x's. If this was, just a little f sidebar, if this was x squared equals 5, then yeah, now you could take the square root of both sides, right? But since we have variables on the left and right-hand side, we can't apply the square root method. So again, what we're going to have to do is set it equal to 0. So we have x squared. So I'm going to subtract the 5x on both sides. So we have x squared minus 5x equal to 0. Again, just subtracting the 5x on both sides. Now, I don't have a trinomial, so it's like, well, what can I factor here? Well, in this case, you want to look for like their common factors. And you can see the common factor here is going to be an x. Both of these terms can be divided by x. So by factoring out an x, I'm left with an x minus 5 equals 0. And now you can see is, again, we can apply this zero product property. It's kind of like what we had, the problem up there. So now we just set them both equal to 0. So therefore I have, let's just write the solution set. X is equal to 0, and as well as x equals 5. Okay, sorry about that. Okay, on the next one. Now, immediately people will look at this and say, well, let's go ahead and apply the zero product property again, right? It's already written as a factor. It's factored out. But the problem is it's not set equal to 0. It's set equal to negative 2. So when we're looking at it, we don't have like the negative 2 product property. We have the 0 product property. So that means what we need to do is set this equal to, what that means is we need to go ahead and set this equal to 0. Well, you could add the 2 over there and set equal to 0, and that's fine. But we're still going to we're not going to have much we can do in this case if we just add the 2 over there and then set equal to 0. Like if we just rewrite this as x times x minus 3 plus 2, we're still kind of stuck because we don't have this written as a product here, right? So we can't like set one set equal to 0 and the other one set equal to 0. So what we need to do in this case is multiply out the x times the x minus 3. So x times x is x squared. X times negative 3 is negative 3x equals negative 2. Then I could add the 2 to the other side now. So when I add the 2 to the other side, I get x squared minus 3x plus 2 equals 0. Now I have an expression equal to 0. Now I can apply the zero product property. I'm going to factor this over there because I kind of ran out of space. What two numbers multiply to give me 2, add to give me negative 3? That's going to be x. Let's see, since they're adding to give me a negative middle term, that's going to be x minus 2 times x minus 1. Sorry about that. And therefore now I can set each product equal to 0. So x minus 2 equals 0, add 2 to both sides. So my solution set in this case is going to be 2 and 1. Okay? Okay, so now moving on to the next problem. Here's we have x squared minus 4 equals 0. Now in this example, we don't really have a trinomial. And so it might be kind of confusing again. We're like, well, how do we do like the added middle terms? And you could still rewrite this actually. You could actually do the middle terms as x squared, plus 0x minus 4 equals 0, and then kind of apply the same method that we use for trinomials. Or you could also understand that this is a perfect or difference of two squares, so therefore we can factor it using that special factoring technique, which rather quickly can just be written as x minus 2 times x plus 2 is equal to 0. And again, if you multiply that out, you notice that the middle terms with the x's are going to add to 0. So now I can set them both equal to 0 and solve, and you can see my solution set is going to be plus or minus 2. Okay, now let's go and move on to the next one. And now we're going to be dealing with trinomials when our a is not equal to 1. And what I mean by a is not equal to 1, I'll actually write that over here. The standard form of a quadratic is ax squared plus bx plus c. And that's important for the quadratic formula, but it's also helpful in factoring this, understanding that the coefficient of our x squared is represented by a. And in all these problems that we did, a was always equal to 1. The coefficient of x squared was always equal to 1. So in these next examples, oops, did I not cover that? Okay. So in these next examples, we don't have a is equal to 1. So we're going to have to look into some different ways. We also have another variable as well as some new notation. And I want you to understand that it doesn't really matter what your equation is equal to. We're trying to find the values of x. When we're solving a quadratic, we're looking for the values of x that make it equal to 0. So if we have a relationship of y equals this expression, that's fine. But again, we're looking into solving. We're just going to replace y with 0. So you can just forget about that. Forget about that the y is there and just set it equal to 0. Okay? Because the y is important, like when we're dealing with the equation and like points on the graph, but for solving, we're looking for the values of x, or finding the zeros. We're looking for the values of x that make the equation true when it's equal to 0. So therefore, we can just replace y with 0. Now, the first thing to do when you have an a that's not equal to 1, if it's a negative number or if it's another number, always look to factor it out. And when it's just a negative, the easiest thing to do would just be factoring out a negative 1. So by factoring out negative 1, I'm now left with x squared plus 7x plus 6. So remember, by factoring out the negative 1, what that does is that kind of like flips the sign here of all of those expressions. Now, what do we do with this negative 1 here? You could apply the, you don't want to apply the zero product property here, like saying negative 1 is equal to 0, because that's not true. So one thing you could do is just divide out. This number is multiplied by this quantity. So if I just divided out a negative 1 on both sides, that would go to 1, and then that would go to 0. So having this, what we call a multiplier, or this extra factor, is not actually going to be affecting our values of x in any way. It does affect the graph, but it doesn't affect the solutions to the equation. So I can really just disregard this number since it's being multiplied by there and there's no x there. So therefore, I need to factor this. What two numbers multiply to give me 6, but then add to give me 7? Well, that looks like it's going to be 6 and 1. So therefore, I can just rewrite this as x plus 6 times x plus 1. Now I can apply the zero product property, x plus 6 equals 0, x plus 1 equals 0, and therefore you subtract a 6 on both sides, so you can say x equals negative 6 and x equals negative 1. Just do it a little different, no solution set. And again, just a little FYI, how did I get rid of this negative 1? I just divided by a negative 1 on both sides, and I didn't show my work there. 0 divided by negative 1 is 0. Negative 1 divided by negative 1 is a 1, and you don't really need to write the 1 there. So that's kind of where that came about. All right, so in the next example, now we have this f of x, and hopefully you're familiar with functions, but if not, f of x is again just referring to a function notation as the output value, and again it's really the same as y as far as like representation of output values. We just use it. It's just a different notation talking about functions, which is a more special relationship. Regardless if we're talking about y's or functions, we're trying to find the values of x that make the equation true when it's set equal to 0. So we really can just disregard this f of x and just set it equal to 0. Now the next one, we have a 2. And so as 2 is my a. So again, the first thing I'm going to do is, can I factor out a 2? Can I factor out that a? And you look at this, and all my 3 terms are divisible by 2. So if I factor out a 2, which is basically like dividing out a 2, you basically take each term and divide it by 2. And when you do that, you'll get an x squared plus 4x plus 4. Okay? And then again, if you want to get rid of that 2, you don't set this equal to 0 because there's no x there, right? And 2 does not equal to 0. So you can just divide by 2 to eliminate that. And therefore, you'll be left with 0 equals. Now, let's look into factoring this. What two numbers multiply to give you 4 but add to give you 4? The answer is relatively, hopefully simple for you. It's saying, well, it has to be 2, right? 2 times 2 is 4 and 2 plus 2 is 4. you could rewrite it as x plus 2 times x plus 2. Actually, let's do it a couple different ways. Let's write it like that. So x plus 2 times x plus 2. And then you could see this is kind of like what we did before, is we have a repeated 0. When I set x plus 2 equal to 0, my 0 is going to be x equals negative 2, but it happens twice, right? It's what we call a repeated 0, or it has a multiplicity of 2. So either way, we can just say that the solution is going to be negative 2. I want to show you also, you could rewrite this as 0 equals x plus 2 quantity squared. And then in this case, what we do is we take the square root of both sides, and then still, once you take the square root of both sides, you get 0 equals x plus 2, and then you could subtract the 2 on both sides, and you get x equals negative 2. Still, it's going to be a repeated 0 or 0, negative 2 with a multiplicity of 2, but again, we'll get to that later. All right, last example for the factoring is, again, we have function notation. Don't really care about function notation, not for at least this problem. And now we need to factor this. And so when you say, trinomial, what two numbers multiply to? Oh, this messes everything up. So if you remember in my factoring practice, I want to set up my two binomials because I know that's what it's going to. The factoring of trinomial is going to set up a two binomials. I'm going to want to have a 2x squared. Oh, sorry, not a 2x squared, a 2x, and then times x. And again, 2x times x gives me 2x squared. What two numbers are going to give me 2? Well, there's a couple different ways you could do this. You could put a 1 here and a 2 here. But again, what we're trying to do is we're trying to add these up to give me 5x. So we know that 2 times 1 gives you 2, but when you check the inner and the outer terms, 2 times x is 2x, 2x times 1 is 2x. But 2x plus 2x gives you 4x, not 5x. So that's not going to work, right? So what if we flip them? What if we put the 2 here and the 1 there? Well, again, 2x times x is 2x squared. 1 times 2 is still 2. But now we have 1 times x is 1x, and then 2x times 2 is 4x. 4x plus 1x is 5x. So now we can just set these both equal to 0 using our 0 product property. And just notice, guys, I'm not showing like the exact same steps for each problem, and that's just for time purposes, as well as just to show you that, sometimes I'll show exactly the steps, what I'm doing, and sometimes I'll just talk my way through, but you should understand the setting each factor equal to 0, using inverse operations to solve for x. You could write it in set notation from here if you wanted to, or you can just leave it as that. All right, finally, the quadratic formula. So you could do all of these problems in the factoring form by the quadratic formula, but once you get really good at factoring, you realize that the quadratic formula is not a faster way than factoring. So as long as you have the basics of factoring, that should be your preferred method. However, there will be problems that may be difficult to factor or that are non-factorable across real or rational numbers. So you'll want to use the quadratic formula. And again, we want to use the quadratic formula when we have our quadratic in standard form. And just to remind you of the quadratic formula, it is x equals, because again, remember, we're solving for the values of x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right. So our main important thing, one thing I taught in Algebra 2 is, identifying your a, b, and c. So like my a in this case is 1, my b in this case is 4, and my c in this case is 1. And basically all you're going to do now is just plug in those values. Now again, we don't really need to worry about what it's equal to 0 because we're finding the values of x. Notice when I solved over here, I was saying x equals this, x equals negative 1, right? So in this case, the formula is set up as x equals these values. So it doesn't really matter what our factor is solution for. It does need to, we want to make sure we don't have any numbers over here. I don't think I did an example like that, no. So we do want to still have it. We want to make sure that everything is in standard form. It's either set equal to 0 or y or a function, but as long as there's no other numbers, we're okay. So now I'm just going to set up my formula and plug things in. So I have x equals opposite of b, so that's going to be negative 4, plus or minus the square root of 4 squared, which is going to be 16, minus 4 times a, which is 1, times c, which is 1. Actually, you know what? Let's just write it as it is. 4 squared. And then that's all over 2 times a, which is 2 times 1. Okay, so now you can see how I've taken my numbers and I've plugged them in. Now, for each number I plugged in, I usually, a lot of times I'll show this. I like to put things in parentheses. And by putting them in parentheses, that just recognizes or reminds me that, that was my opposite of B. That is my B. My A, my C, and my A. So it just reminds me of me plugging in those values. So now let's go ahead and simplify this. So I have x equals, so -4, obviously that's -4, plus or minus. I'm going to do a little bit of math here. 4 squared is 16. 4 times 1 times 1 is 4. So 16 minus 4 is 12. That's kind of a really big radical symbol. So let's maybe close that off. And then divided by 2. Now, technically, you're done. That is the answer. But we want to usually simplify this. And we know that we can simplify the square root of 12. Kind of a little sidebar. We could break that down into the square root of 4 times 3, right? So that would be 2 times radical 3. Simplified. So if I rewrite this now in that simplified format, I would have x equals -4 plus or minus 2 radical 3 divided by 2. And now what we see is, again, these answers are equivalent. This one's a little bit more simplified with a simplified radical. But now you can see this 2, by like division distributive property, this 2 divides into both those terms. So an answer you'd probably see like on a test or that your teacher or professor would look for would be 4 divided by -2, which is -2, plus or minus 2 divided by 2 is 1. So it would look like that. So that would be technically our simplified answer for that problem. All right, so let's move on to the next one. And for this next one, I'll just go ahead and use green just to kind of change it up. So we have A in this case is 4, B is 3, and C is going to be a -3. So make sure you kind of keep that sign there. That's a -3 there. Okay, so again, let's just plug them into the formula. X equals opposite of B, which is 3. Plus or minus square root of b squared, which is going to, let's just write it as 3 squared, minus 4 is going to be 4, times c, which is a -3. Now, it's really, really important to have that -3 there, or at least to understand that c is -3, not just a +3. And then we multiply this by 2 times a, which is 4. Okay? So now let's bring this down and let's go ahead and simplify. So we have -3 plus or minus. Now we have 3 squared is 9. Now this one might not be as easy to multiply out. So let's go ahead and just do it a little bit extra steps. So we have 3 squared is 9. Now I have -4 times 4, which would be a -16. -16 times -3, so 16, 32, 48. But it's a negative times a negative, so it's positive 48, and that's all over 8. Then we have x equals -3 plus or minus 9 plus 48 is going to be 57. And then we want to think, like the last problem, we could simplify the radical, right? Well, square root of 57, there's no square numbers that I can think of that evenly divide into square root of 57, so that's going to be your answer. Now, again, to kind of further write this problem out, we could still divide the 8 into there. You might see the answer look something like this. X equals -3/8 plus or minus like 1/8 times the square root of 57. Like that is one way that we could write the answer, or this. I mean, they're both right. It's just different ways of writing the answer. All right, last but not least here. So now, again, we're going to identify. Let's go over to blue. So we'll say A is 3. B in this case is 1. And then C, we have a +1. So plugging them into the quadratic formula, we have opposite of B plus or minus the square root of 1 squared minus 4 times A times C, all over 2 times 3. So now in this case, we're going to go and do the same thing. So we have -1 plus or minus. Let's see here. Square root, can we do this? Yeah, I think we can do this in our head. So 1 squared is 1. And then here, this is going to be a negative product. So -4 times 3 is -12. Right? And then times 1, so it's -12. So we have 1 minus 12, right? So it's 1 minus, and then this product is 12. Well, that's going to equal negative 11 divided by 6. Now, again, negative 11, we can't simplify, nor can we take the square root under our real number system. So therefore, then we want to look at, well, we could talk about our imaginary number system again, and going into, remember that I is equal to the square root of negative 1, our imaginary unit. So I could rewrite this as x equals negative 1 plus or minus the square root of negative 1 times the square root of 11. That way, all divided by 6. Now, what that allows us to do is rewrite the square root of negative 1 as I. So an answer as far as like the complex solutions. Now, if the directions or something was just talking about the real solutions, you would say there are no real solutions. But we do talk about complex solutions, in the class. So it is kind of important just to remember the plus or minus here. In this case, it would be I square root of 11 over 6. Or we could also write the answer as x equals negative 1 over 6 plus or minus I over 6 times square root of 11. Or actually, I wouldn't write it like that. We'd say I times square root of 11 over 6. Okay, so there you go, ladies and gentlemen. That is our review of solve quadratic equations. Thanks. Well.